Hi everybody, welcome back. In this video, we're going to talk about why would we use a container. So in the last video, we talked about kind of what is a container. Now we're going to talk a little bit about why would we use it. So these are not in any specific order, but I kind of feel like the way that I teach this in my brain, or the way that I think of this in my brain, they kind of flow. So the first thing let's talk about is transportation. And no, I'm not talking about a city bus. I want you to think about how you typically go through your development process today, right? You need to go to your VMware admins and you need to say, hey, we're deploying a new application. Can you give us a development server? And they say yes, and that takes 2.5 months for them to go through the approval process. And then of course, they finally give you your VM, and what do? You log into it and you start developing. And then of course, you need to do that again for QA, and you need to do that again for production. I want you to imagine this for a minute. In today's day and age, we have WSL, so I can have a Windows 11 machine and I can deploy Linux on it, right? So I can actually have a Linux virtual machine running in my Windows laptop. I can also install VMware Workstation. I can do the same thing. Or I can actually just have a Linux laptop, a machine that's running some kind of Linux. Regardless, let's just say that on my personal machine, I install a container runtime, a container engine, and let's just say that the base is going to be Linux, so that we can move it, because again, you can do this with Windows Docker as well, but I'm more familiar with Linux, so that's just what I'm going to use. So I go and I develop this container, this application that I need to develop on my laptop. When it comes time to move this to QA, I don't need to do anything. And what I mean by that is all I need to do is I need to take this container and I need to move it to a server. Maybe that server is living in the data center, and I need to just take that exact container and move it from here to here. Think about how you would do this in VMware. You would have to export that into an OVA or an OVF, or you'd have to, you'd have to give your VMware admins the VMDK file. But think about the work that takes, right? This could be a 40 gig VMDK. Right? Or this could be, a 40 gig OVF file that you have to give your VMware admins that image. Well, this container doesn't use that much, and I'm going to get to that in a minute when we talk about resource utilization. Think about the process of doing that. All I need to do is ship this minimal container from my laptop or from my desktop or from whatever I'm doing it on. And this could still be a QA server, right? I'm not saying this shouldn't be. This could still be some VM that you have living in your data center that your VMware admins gave you. The point is that I don't really have to do that much to take this container from the development perspective, from the dev point, and move it to QA. And when it comes time to take that container off and say, hey, okay, now we're ready to move it into AWS, or we're ready to move it into my cloud provider. Maybe in AWS I have, an EC2 instance, or maybe I have EKS. I don't know why I just wrote that as dyslexia in action. Which this is Amazon's Kubernetes as a service. Kubernetes is an orchestrator that helps with automation. I'll get into that and again in a few minutes. Sometimes it's hard to not put the cart before the horse, if you know what I mean. But again, the transportation of containers is super easy, right? The ability to just take this container and move it from one spot to another relatively easily without having to go through this huge migration period is awesome. Now, I mentioned something, I kind of alluded to it here, this 40 gig VMDK file. Resource utilization is a big one when it comes to why we would use containers. Containers are not measured in the same unit of measurement as a regular VM, right? In a regular VM, you're like, okay, the operating system is going to take, 18 gigs, and then all the packages, everything I need to install. Okay, I need a 40 gig hard drive at minimum, and if you need, let's say 10 containers, you need 400 gigs of space living on the SAN in order for you to have those 10 VMs to do those 10 things. Well, the resource utilization in a container is measured in megabytes. So you're not going to have the same storage requirements when you go to run those same containers. So you can build a single VM with that 40 gig of space, and you can still run those 10 separate applications on 10 different containers, and you're only using what could be 100 megs out of that 40 gigs rather than having to replicate that each time. The same thing is going to go for your CPU and your memory, right? You're not going to have to replicate, okay, the 10 or 15 gigs of memory and the 2 cores or 4 cores or whatever else you're going to throw at this. You don't need to do that, right? And the reason is because if you remember when we were talking about what is a container, we already have the operating system, we already have the binaries, we already have the libraries that are included in that container, and we don't need to replicate these every single time we deploy the container. I just realized I kind of messed up. I was drawing on top and I kind of did this. So let me just erase this here. Sometimes I get carried away. So we'll put this on top, and this way things are consistent. I don't want you guys getting confused. CPU, oh, I already wrote that. So OS, the binaries and the libraries. Yeah, this way we're consistent. So we're already replicating this, right? So we don't need to continually do that. And in the long run, all of this is going to save us money because we don't need to continually replicate this across the board. So resource utilization when it comes to containers versus traditional VMs is huge. Now, this kind of leads into the automation and the orchestration, right? Because think about, again, not only what you have to go through to deploy these, but think about what you have to do in order to automate this. So let's just say that we have a customer portal, right? Let's just say this guy's out on the interwebs. And let's just say that this customer portal gets hit, let's say 20,000 times during the day, right? So this customer portal, this web portal gets hit 20,000 times during the day. But let's say at night, it only gets hit, let's say 100 times, right? So we'll put it over here, only 100 times during the evening. But during the day, it's 20,000 times. Well, I don't want to go and spin up 10 web servers in order to handle the amount of incoming traffic, right? I don't want to go spin up 10 database servers and 10 web servers, right? So essentially this is times 20. So I would need what, 800 gig of storage space. I would need X amount of CPU, X amount of RAM in order to support that. I would need how many VMs, et cetera, blah, blah, blah. I don't want to continually do that and leave it running if I'm only worried about that peak utilization during the day. Right, what I really want to do is I want to have, let's say, 100 web servers or 10 web servers, whatever I decide I need during the day. And then at nighttime, I want to decrease this, right? Maybe I only need 5 at nighttime because I'm only getting, 100 hits, right? So what we can do is we can actually throw an orchestrator in front of this like Kubernetes, right? We're just going to call this Kate's. Right, we'll get to this again. Hopefully we'll get to this in this video series. If not, in the next video series I do on containers, hopefully we'll get to it. But either way, it's the same concept, right? So we can throw some kind of an orchestrator like Kubernetes, like OpenShift in front of these things, and we can say, okay, look, during the day, what I want to do is I want to automate this one container. I want to take this container and I want to multiply it 20 times, and I want to have 20, 40, 80 containers that are running and replicate this out. I want to scale this so that during the day, during the peak hours, 20,000 people can hit it. But then at night, after, let's say 8 to 5, so after 5 p.m., I only want to have 10 containers running or 5 containers running. And this can all happen while we're watching reruns of The Office. Now I realize none of us watch YouTube in the office, quote unquote. Right, your boss may be listening, but let's be honest, right? We all have a second screen for some background noise where we're watching, Office Space or something like that. So, we can automate this. We can scale it based on our needs, again, without having to throw resources at this, right? And we can move those containers anywhere that we need to, hence the transportation, without having to constantly go back and say, all right, we got a vMotion, this, blah, blah, blah. We can throw, again, an orchestrator like Kubernetes at this, and Kubernetes can go and say, hey, I have 3 VMs that I'm responsible for running these containers, and I'm going to go ahead and load balance these 20 containers across those 3 machines. And so this way it's always load balanced, it's always taken care of. And if anything happens with those containers, I don't care because I have 19 other containers, and I'll just take that one offline and build another one because maybe I want to make sure that the minimum amount of containers I always have is 20. There's all sorts of stuff that we can do and automate this, right? And again, a service like AWS can do this for us as well. Now, I didn't really dive into the networking architecture of containers, which is where the security comes in. I'm going to do that a little bit now, depending on how far I get now. Again, I'm doing this off the fly. These are just bullet points that are put here to spark my memory and teach you guys how it works. If I get far enough here teaching this, then I probably won't do a network video. So if you don't see one, you know why. If you do see one, then you know that I have more to show you. So I want to imagine something here for a second. I'm going to use this for my whiteboard space. Let's imagine that this is my core OS, right? So this is my actual virtual machine, okay? So VM1. This is where I actually have my operating system. Now, this operating system is obviously going to have a VNIC, right? So here's my VNIC that goes out to, the rest of the world, right? That's where I actually give the IP address of my host, my virtual machine. Now I go and I spin up a container. Now, by default, this container is going to go into something called a pod. So here's my app, right? We're going to say app 1. I didn't make that big enough, but app 1. Now, this container is going to have its own VNIC. Now, I can go ahead and I can add more containers into this if I want to. So I can have 2 and I can have 3. Now, inside of this pod, we're just going to call it pod 1 for reference. Inside of this pod, these containers can talk openly. They can do whatever they need to do. But I can also control what this virtual VNIC for that pod is allowed to do and not allowed to do. The same way that I can control what this virtual NIC can see and do. So I'm actually adding a level of security on top of my normal traditional VNIC. So let's just say that I'm using something like Cisco Secure Workload, or I'm using something like NSX, or I'm just using a traditional firewall to control where this guy can go. Now I can also use, again, something like Cisco Secure Workload to control what this NIC does. So now I'm adding levels or layers of security. And it's the same thing if I go spin up another application. This is going to go into its own pod. So we'll say pod 2, app 1, maybe pod 3, app 1, right? And all of these different pods are going to have their own VNIC. So I can say, hey, this VNIC for this application, for this pod, is not allowed. Let me pick a different color. We'll pick, I hope blue turns out, is not allowed to see this pod. So pod 1 and 2 can't talk to each other, but pod 3 and 1 are perfectly allowed to talk to each other. That's okay. So I'm actually adding a layer of application security within that VM by deploying containers. So these are kind of the 4 big reasons why I would personally deploy containers if I'm in a situation where I kind of need these things, these capabilities. So I hope you guys enjoyed this video, and I'll see you guys in the next one.